Hello friend, welcome to Dr. Subhash Technical Campus, Junagadh. Here, today's tutorial topic is field effect transistor, means simply it's called FET. This topic is covered in basic electronic concept. Also it is available or used for power electronics. Now let's start. First of all, let me start with basic definition. Here, FET is also known as JFET, means Junction Field Effect Transistor. In this definition, you have to remember this word unipolar. Means JFET is unipolar, which act as a voltage control current device and is a device in which current at two electrodes is controlled by the action of an electric field at a reverse bias PN junction. Means, first of all, let me start with unipolar. What is unipolar? Means only one polarity is required to flow the current in FET, either electron or hole. Means these two particles is not required at a same time. Only one particle is used to required for flow the current. Also, voltage control current device means here if we control the input voltage, then output current is controlled. So it is called voltage control current device. And it is a device with two electrode, means current is controlled by the two electrode by the action of a electric field at reverse bias junction. In this structure, we will see later the PN junction with reverse bias characteristic will limit the current between drain and source. Now let's see the basic concept. This is the symbol. Here mainly two type of FET is available. First one is N channel JFET and second is P channel JFET. Here in symbol we can see the three terminal gate, drain and source. Here also in P channel, gate, drain and source. But here you have to remember this arrow on the gate. If arrow is inside, then our JFET is N channel. If arrow is outside, then our JFET is P channel. So you have to remember the arrow, direction of arrow. If we change the direction of arrow, then total device will change. Means if we change the arrow direction of arrow, then N channel or P channel will different. So this is the basic symbol of FET. Now few important advantage of JFET over the conventional transistor. Means if we talk about the transistor, then transistor is a bipolar device. Here FET is a unipolar. The first advantage, FET is a unipolar, either hole or electron is required to flow the current. Second, voltage control current device means if we want to control our output current, then we have to change the voltage. Means if we change the gate voltage, then drain current is changed according to the input voltage. Then third one, high input impedance means if you want to design an amplifier with high linearity, then input impedance should be high. So FET is more suitable than BJT. Then fourth, source and drain are interchangeable when most low frequency application. If our application, main application of the amplifier with high frequency amplifier as well as low frequency amplifier. If we talk about the low frequency application, then drain and source can be interchangeable. So it is easy to design a circuit. Then fifth, low voltage, low current operation is possible. Means if we talk about the battery operated any instrument, means low power application, low voltage and low current, at that time FET is more suitable than BJT. Then loss of noise or less noise compared to the BJT. The FET, whenever we talk about the FET, then less noisy component than the BJT. So the noise is nothing but unwanted signal. So if unwanted signal is very less, then our actual output is very good. So this is the most important. Then 7, no minority carrier storage, turn off is faster. Means If we talk about the high frequency application, then turn on and turn off characteristic should be sharper. At that time, the minority storage or carrier storage is small, then or no, then our switching is very fast. Then self-limiting device also compared to the BJT, FET is a self-limiting device. Then 9, very small in size, occupy the very small space in IC. If we talk about the total instrument size, then individual components should be very small. If we design a very small individual component, then our instrument become very small. So it occupy the very small space in IC. If we talk about the integrated circuit, if you want to design IC, then FET is more suitable than the BJT. Then number 10, low voltage, low current operation is possible in MOSFET. Now MOSFET is a higher version of FET, means metal oxide semiconductor field effect transistor is a higher version of FET. So we can design a MOSFET using the FET. So it is possible to low voltage and low current operation. So this one are the basic important advantage of the FET. So you have to remember this all are the advantage. Now different types of field effect transistor is available. Here you can see in table the different type of, first one is JFET, the mainly JFET and MOSFET, or is also known as IGFET. The JFET is also divided in two parts, N channel JFET and P channel JFET. If we talk about the N channel, then majority charge carrier is electron. In P channel, the majority charge carrier is hole. So this is the basic difference in channel. And the MOSFET is divided in two parts. First one is enhancement type MOSFET and second is depletion type MOSFET. So here enhancement and depletion type MOSFET, two type of MOSFET, also it divided in two parts, N channel and P channel. Here also N channel and P channel. The MOSFET will cover in next video. In this video we will cover the N channel JFET and P channel JFET, basic fundamental of the FET. So friends, you have to remember, or you can screenshot this slide so you remember the classification of the JFET or classification of field effect transistor. Okay, then let's start with the junction N channel JFET, or N channel JFET is nothing but, first of all you have to take N type semiconductor. Now we familiar with the N type semiconductor. Here N type semiconductor is nothing but whenever the majority charge carrier is electron and minority charge carrier is hole. And here the channel, this blue portion is made up of channel, means it create the channel. So let's start with one by one point. The first, this is the N type semiconductor, this is the P type. This two P type semiconductor is nothing but is the gate. Whenever you connect the gate to the three terminal, first one let's start see the old diagram, then we can understand easily. The first terminal is drain, then gate and source. The connection is like this. So we can see that, or we can say that the FET is a three terminal device, drain, gate and source. And if we talk about the symbol, then this is the symbol of the JFET. Here arrow is inside and drain is upper terminal and lower terminal is source. Here one PN junction, two PN junction is created actually. Here this one is P type semiconductor, this is also P type semiconductor, and this is N type semiconductor. In between P and N, here one junction is there, here also one junction is there. Whenever we apply some voltage to the gate, and according to the gate voltage, here depletion region will created. If this junction or this junction is in reverse bias, then increasing of the input voltage, gate voltage, the depletion region width is increased. If this junction is forward bias, then this depletion region width is decreased. So the width of depletion region or depletion layer is proportional or inversely proportional to this gate voltage. So here most important you have to remember the gate voltage is a controlling voltage, and this channel width, this is known as channel width. Channel width is nothing but the path between these two gate terminal is known as channel width. If this channel width is very narrow, then low current. If channel width is very broader, then the current is very high. This will understand in next slide. Now this is the structure of the P channel JFET. This is the material of the P type semiconductor material. Here in P type semiconductor, the majority charge carrier is hole and minority charge carrier is electron. Hole and electron. Here only we have to talk about the hole because the hole is a majority charge carrier. The construction is like this. Here also the depletion region, drain, source and gate. Here the terminal name is drain, gate and source, and this is the symbol of the P channel JFET. Here the upper terminal is drain, gate and source, and this N type region is gate region, and this is the channel. Here the channel is made up of P type semiconductor, and in between these two gate there is a channel, and this is also the channel width, and channel width is decreased, then according to the channel width decreasing, the current is also decreased. But here you have to remember the current is due to only hole because this is the P channel JFET. If our channel is P channel, then only hole is participate in the flowing the current. This is the symbol of the JFET, P channel JFET. The arrow is outside the gate, outside the gate terminal, and drain is upper terminal, source is lower terminal, and you have to remember this the symbol of the P channel JFET. So this is the basic construction of P channel in N channel. Now let's show the operation of the JFET. First of all, we start with N channel JFET. Here this is the DC voltage source. If we increase the DC voltage source, then this is the reverse bias voltage is increased. Here this junction is in reverse bias mode because here we give negative voltage, and also in source we connect with positive. So the VGS voltage is a controlling voltage. If we increase the VGS voltage one by one or slightly, then the region of depletion region will increase, and at the same time the current is decreased. So let's see the one step by step. First of all, here the voltage is small voltage. Here the DC voltage is small. If we increase the DC voltage, then this green layer indicate the depletion region width is increased. So the channel width is decreased. This channel is become narrow, and the current is also become small compared to the previous step. So the green voltage is applied voltage. Here some green voltage is increases. Now next step, if we increase the voltage further, then what happen? This type of region is created. This blue region or this the channel width is narrower, and current is also decreased. Now further we increase the voltage, then what happen? If we increase this much of voltage, then this channel become very narrow or zero. This condition is known as pinch off of FET. Now at the time of pinch off, there is a very small current, very few microampere current will flow from drain to source, and current become constant. So this you have to remember the pinch off word for the JFET. If we talk about the characteristic of JFET, then pinch off is most important for the characteristic of JFET. That will see in the next video. First of all, you have to remember this type of characteristic or this type of idea for the designing of the JFET. Now in this slide we have seen if we increase the voltage, first of all this first green voltage, then blue, then red voltage, then what happened? If we increase the voltage, then the channel width will decrease and depletion region increase, so the current become very small. So at the time of this two depletion region will touch each other, and it become pinch off, and current become constant. This is very important for the JFET. Now physical operation under the VDS is equal to 0. Means VDS is 0, then no voltage between drain to source. At that time what happen? Whenever VGS is 0, then the channel width is like this. Here some channel between the drain to source, and drain to source current is more compared to the all other. If we less than 0, if the VGS voltage is less than 0, then what happen? The depletion region width is increased and channel width become very small. So the current is also become small. This is this type of criteria. Here this VGS voltage is increase or decrease according to this criteria. First of all, it is equal to 0, then less than 0, then next one, if VGS is equal to VGS off, then what happen? Means pinch off. This condition is known as pinch off. There is no channel between drain to source. Only minority charge carrier will participate in the current. So the minor current will flow from drain to source. So simply you have to remember, pinch off is nothing but whenever VGS is equal to VGS off, then it's called, this condition is known as pinch off condition. So friends, you have to remember this three figure. If VGS is equal to 0, then channel is there. If VGS is equal to less than 0, then channel is very narrower. If VGS is equal to VGS off, then there is no channel, only few current, micro current will flow from drain to source. So this one is about the some operation of FET. And friends, you have to remember the FET is a higher version of BJT, bipolar junction transistor. In BJT, there is a hole and electron, both are required to flow the current. Here only one, either hole or electron. If our FET is N channel, then only electron is participate in the current. If our FET is P channel, then only hole is required to flow the current between drain to source. So this one is about the FET. Okay friend, thank you. If you have any query or doubt, you can write on chetanb@drsubhastech.edu.in. Okay, thank you.